Hello, everybody. My name is Derek Kominick. I'm the marketing director at Matricon. We are a part of Honeywell, but we run as a standalone brand, let's say, so individual group. And today we'll be talking about one of my favorite topics, OPC UA security, and basically why is it secure by design. So before I launch into the details of what we do inside the actual spec itself, just some background. You know, we hear a lot about IIoT, about how things are connecting or interconnecting increasingly, both at every layer in a company, but also going out into the cloud and such. So there's more and more interdependent systems. It's pretty clear why we have a need for increased security as we increase connectivity, since like a stack of dominoes, if you don't have things secured in the in-between connections, obviously things can sort of cascade when systems are attacked, either on purpose or just by accident. So given that, when we talk about system security, really the key point we're trying to zero in on is trustworthiness. So in the OT world, we have some quite stringent requirements for what's necessary for security, but also to ensure that the plants are running. And at the same time, in the IT world, we're of course seeing a lot more mix now through the IIoT. There's also quite an advanced concept of security. So IIoT, sort of Industry 4.0 stuff, brings it all together. But trustworthiness, really the key sort of aspects of that are safety, security, resilience, reliability, and privacy of data. So when we look at OPC UA, this is the sort of the task that was before the OPC UA standard, let's say, to see if it could become, let's say, the backbone for these types of IoT architectures. Interesting point, OPC UA was actually developed before, let's say, the wave of IIoT or just the whole Internet of Things sort of craze in the era started. But just the way, from lessons learned from Classic, what was already created actually fit very well, kind of hand in glove for what IIoT needs now. But OPC UA is actually born and built from the OT environment going outwards. So there's a lot of trust in the industry for what that standard does. Okay, so the key concepts that we want to talk about when evaluating how secure a system is, security professionals will look at sort of 6 overall concepts. They're grouped into 2 different groups. First is the CIA triad, and that stands for looking at the data confidentiality, integrity, and availability. And then as well, another set for sort of who gets to access the information and how, that is the AAA principle. So authentication, authorization, and accounting, or basically the auditability, the ability to audit, who did what. Okay, so those are the keys. So this is the backdrop against which the security within OPC UA could be judged, or also the mechanisms that were set up were to protect these particular aspects of security. All right, one final thing, security is a very broad topic. So when we talk about OPC UA, it fits a particular slot in the whole, let's say, security universe, right? So when we talk about data, it could be at rest, how you store it, how you protect it in storage, data in process. So when applications are actually working with the data, is that a secure way? Because the applications themselves could be hacked to then get at the data. And then there's data in motion, which is purely transferring the data between point A and point B, with possible hops in between. OPC UA is squarely focused on that. So everything that we're talking about here is focused on security of data in motion. All right, so let's jump into OPC UA. So first, OPC UA is the next generation of OPC in general, which started with OPC Classic. The first focus of OPC Classic, which sort of, let's say, revolutionized communications in the industrial world by going to an open standard where things, you moved away sort of from the proprietary vendor lock-in type communications. So that started off in the process or the operations side. But now with OPC UA, of course, that's expanded greatly, sort of rewrote the book as far as communications and what's needed for them, right from the deepest levels in the shop floor. And as you know, so for example, the FLC, the field level communications, where we're talking down to devices out in the field, and let's say at the lowest level, sensors and such, and at the same time moving upwards all the way up into ERP and beyond into cloud. So there's a lot more requirement to ensure that all of this fits together. And one of the key things here, takeaways, is that OPC UA is sort of all-inclusive. Everything is built in and it's integrated. So regardless of which level you're looking at, the security is uniform, right? So there might be changes that get brought in or adjustments done as algorithms change over time as is necessary. For example, the encryption algorithms and such, as the bad guys get better, the good guys get better. It's a cat and mouse game in the world out there. The standard moves forward with that, but the point is that all of that still stays integrated, so you have one uniform method of ensuring security across your organization. Okay, now when we say OPC UA is secure by design, we really mean it. When you look at the parts, the way we currently number the different parts of the entire standard, there is a large number of sections which deal directly with the security. So it's not we just have one section that talks about which algorithms you're going to use for security, and there you go, you're done. It actually, for the different types of access that you do and how they interact with the other capabilities that are built into the standard, security is woven throughout the standard. So really it is built from ground up to be secure, both on paper and also the way you actually implement it. Now, the way we structured OPC UA security is in layers, let's say. So we, of course, have our different transport layers, and the transports can be encrypted themselves, so they could have already security built into them, but there are other transports that may not. So on top of that, what we do is we set up a channel, and then when you're connecting, and once a channel is set up, then there are different sessions that can run on that channel. So the channel is basically when you've got when the client and the server, for example, are trying to establish whether they should trust each other or can they even talk at all, based on certificate exchanges to see if they are trusted, and then they build up sort of the infrastructure of how they're going to communicate. So what type of key are they going to share? There's advanced algorithms that are used for that. So that's what we call the asymmetric side of things, or the PKI, where we're establishing the connection. Once that's set up, they also then start to then they identify sort of let's say a faster, more efficient way to work with encryption, which is a symmetric algorithm style, which basically means both sides know what the key is and they just continue to exchange it between each other. But even there, it continues to rotate that key just to ensure that statistically you couldn't start to figure out what the key is that's being used between the client and the server. So it's truly end to end. It's quite active that way on the secure channel, where we again take care of the confidentiality, integrity, and authentication of apps. And then once that's set up, then basically now we get to the real business, which is, okay, so what information is going to be exchanged and who's allowed to see what now that the applications actually are talking to each other. And this is what the application layer comes in at, and we have user authentication, and then also user authorization to say, what is allowed, what each user type is allowed to do. So that's sort of the structure of how OPC UA builds up the security. So again, and I guess I explained this already as we talked. So what happens is the exchange between clients and servers, they exchange certificates. You have to identify if they're trusted or not. If they're not, then they just won't talk at all. If they are trusted, then they start the negotiation to start to identify what key they're going to use again and which cryptographic algorithm is used. That actually happens on connection. I'll talk about that, how that's selected, which algorithms are being used. And then basically once you have that, then you get to the user part where you're starting to identify what the server will provide, which information, which views, etc. it will provide to the clients as they, when once they're connected and they're requesting information. Okay, now how the algorithms are selected. So it's a fairly involved system underneath the hood, where you're identifying which algorithms are used to generate keys, also how the encryption actually itself is done. Different components have to come together to orchestrate the whole communication between, let's say, a client and a server. Now, one nice thing about OPC UA is that it's not a one-size-fits-all standard. So what I mean by that is if you're communicating with a smaller device that's dedicated to indicating whether a proximity switch or something that's quite small, it doesn't have a lot of computing power for what it does, versus talking to a larger PLC or even a full-blown PC system, they will have different compute capabilities. And what that means is that when you want them to integrate into an OPC UA based architecture, they have to be able to act as a citizen of that within that infrastructure, but they don't have the compute power to do the algorithmic calculations, for example. But they may be able to sign, or maybe some of them are so simple they can't even do the signing, and therefore they have no encryption that's used. And it typically goes hand in hand with the type of task that they're doing, right? So if it's a critical task and it's sensitive, then the way the device would be made, it would have more cryptographic, let's say, ability or compute power, otherwise not. So OPC UA allows you to choose which type of, what level of security is going to be used. Servers actually can support multiple kind of combinations, let's say. So as an end user, one just has to know which of the options to choose without having to know what all the underlying algorithm types are, etc. You just choose from which, the ones that a particular server supports, and then everything else is done under the hood. So anyways, those are security policies. That's what we call them. And over time, as I mentioned, if you see on this list, aside from none, which again should be, we strongly discourage people from using it unless you absolutely have to, because for example, you can't use encryption, at least at that level. There are some that are listed here as deprecated. And again, what that means is that, as the either the key is too short or the algorithm used to generate it has been broken. So basically you can reverse engineer it. As time goes on, those will be deprecated. That doesn't mean that devices that have that won't work, but just the point is deprecated in the sense that, of course, not advisable to continue to use it because obviously there are new, better algorithms that continually come out. So it's a living standard. It continues to evolve. Okay, now also OPC UA lives in sort of all the different layers in the enterprise. So whether you're talking down on the shop floor and you're using your typical binary TCP/IP communications, or you're talking outwards towards the cloud, so now you're starting to use sort of the broadcast, or you're doing high-speed sort of cyclic communications, between machines and such. Then, of course, we're moving into the pub/sub world, which works a little bit differently, of course, than the client server. Uwe explained that, so I'm not going to get into that. But the security also, the way that's set up, when we have the publisher and the subscriber, and there may be in between steps, jumps where you're going through brokers and such, for example, if using MQTT. So what happens is the publisher, the server, which acts as a publisher, will identify groups of items that will be published in what we call groups. And therefore, security groups are created for each of those lists of items that are being published. And there are keys for those. So therefore, subscribers, if they have the right key for a particular group, they'll get access to that information. Now, the exchange of the keys is actually still facilitated by client server infrastructure. So even though you have a publisher and a subscriber in a pub/sub world, you actually still stay within sort of the OPC UA envelope as you're setting up that communication, and you're using a client server connection to do the exchange of the keys to set it up. And then again, the publisher registers the different groups that it's going to expose, and subscribers will then access those, and they have of course the key, then they can access the information. So in pub/sub as well as in client server communications, OPC UA does end-to-end security. Now, the one thing that I'd like to also talk about is just the breadth of security topics that OPC UA covers in this space. So in this slide, I'm showing sort of on the left column, basically the most typical and common attacks that are performed on systems, and the columns that show to the right, they indicate which aspect of security or of trustworthiness is being attacked by a particular type of threat. So OPC UA has been designed to address all of these. Now, sometimes things like server profiling of what a server is, which server you're talking to based on the traffic that's sent. I mean, some things can be picked out that just can't be prevented completely, but it could still be, you can minimize the information that you give out about the applications as they communicate. Other than that, though, OPC UA actually has effectively addressed these types of attacks. There were third-party analyses done on the specification, especially in Germany, for example, the BSI, when they contracted third parties to go through and actually thoroughly test this, not just on paper, whether the algorithms work, which is also important, ensuring that you're not inventing your own, that you're using the best practices and such, but also in the real world, when you actually go to implement the specification, can you implement it, and can a standard implementation actually protect or at least to effectively work against these threats. And after extensive testing, the result was positive, and hence why today OPC UA is almost synonymous with Industry 4.0 type technology, and hence you see also, everything else sort of follows along after that. That's why you see so many companion specification groups, etc., because everyone's trying to use this because it provides that security layer underneath on top of all the great modeling and such that we hear about. Okay, now as far as how these are addressed, I won't go through each of these, but what happens is when you, when we talk about each of the attacks, these are just broken out for some of them. There's a particular mechanism inside OPC UA that actually is used to prevent it. So let's say we take message spoofing, where someone's trying to forge a message between the client and the servers, kind of injected in there. So besides message signing, there's also there's session IDs that have to match up. There's a channel ID that has to match up. Timestamps have to match up. So it's kind of a multi-factor security even at each one of these steps, right? So OPC UA doesn't just say, yeah, we encrypted it, now we're good. That's part of it. And encryption, for example, helps against eavesdropping. But as that table showed, there are different types of attacks to attack different types of different aspects of that trustworthiness. And for each one of those, there's been a thorough design built into it to ensure that there's enough data points, like a fingerprint, for each message that comes through, so that the server can be quite, there's a good way to figure out whether whatever requests are coming in or whatever came from a server is actually authentically coming from that server. Okay, so that's all I'll say on that. So to conclude, basically, when you look at all the mechanisms that are built into OPC UA, they're following the best practices. All of that points to really the things that really matter most, which is, again, the CIA triad, so confidentiality, integrity, and availability, as well the authentication and authorization, both of users and the applications, and the auditability, which is extremely important, because being able to go back either to audit the messages, like I just said, that came through, and to make sure that they fit into the sequence of what was being done and by the right people, but also afterwards, if you're doing a post-mortem, to identify where that originated from, because yeah, depending on the situation, either of those are important. So OPC UA has different levels of security that you can implement depending on what type of application you're developing, whether it's a small compute sort of embedded device or a larger system. It can accommodate all of them, and they can all still play in a coherent way, within the same infrastructure. And also, last point, OPC UA does continually evolve, because you can't freeze a certain snapshot or a certain approach to security and just stick with that. That world is continually changing, and OPC UA follows along in lockstep with that. So for these reasons, we would say that OPC UA really does enhance your system security, and it definitely represents a key component in your defense in depth strategy. Okay, so with that, that's my that's the quick talk on OPC UA security. So again, if you guys have questions, definitely I'm happy to answer any, or we can do that in the session when we do the Q&A. So yeah, look forward to hearing from you guys. Thank you very much.